morning, Johannesburg. Hello, everyone. Good morning, virtual people. If you're joining us from the interweb, welcome to my talk. Let's wait for a few people to settle down, and then we'll get underway. All right. So, my name is Chris Tite, and I'm here to talk to you today about integrating distributed enterprise data using data fabric technology. Fairly exciting technology, and I'm very excited to be here presenting to you. I am from a sleepy little East Coast village called Durban, and I run a company called Kaleidocode. I'm the founder, one of the co-founders and directors at Kaleidocode. When I'm not directing people and directing the company, I am a software architect, stroke software solutions architect, or something to that effect. I can't remember the title. So before we get underway, I want to just cover what are we talking about today, so that if you've got another talk you want to go to, or there's a lot of stuff that you've seen already and you think that this may not be important, then let's move on. So I want to talk a little bit about the challenge. It's going to be the same type of challenge. We've got big amounts of data. We've got a lot of data. We've got to be able to process it. How do we do that? Then I want to look a little bit at these ideas called data warehouses, data lakes, and the smelly cousin of the data lake, the data swamp. And then to introduce this concept of data fabrics. What I really like about to have happen today is that when you walk out of here, you actually understand what the hell a data fabric is. We're going to kind of look into some of the workings of a data fabric and understand what it does and where it works and why it's different to a lake. I'm going to show you some data fabric technology. I'm going to do a little bit of a demo of a product. And then I'm going to talk a little bit about Apache Spark, which is the compute engine underneath the data fabric technology, and show you a little bit of code. It's not a lot of code, but it'll be enough code for you guys to go away and actually start playing with some of the stuff in your own working environment. It's a bit difficult to see on the screen right now, but there is a GitHub repository, or GitLab repository, sorry, with the code that I'm going to demo today. And the slides are available on that speaker deck or slide deck or speaker deck URL that you see there. Okay. So before we start talking about data fabrics, we're going to talk a little bit about beer. All right, so anybody who's ever heard me talk knows that I like to share beers for awesome questions. So if you ask a cool question, or if I ask you a question and you answer it, I'm going to throw this weird little ball across to you, and then at the end of the talk, come along and trade the ball for a really cool microbrewery beer from KZN. All right. If you don't like beer, I've got some chocolates. All right. So there's a little bit of a trade-off there. Cool. So the challenge, and I wanted to put it in because it sets us in a nice context. We're going to, at the current moment in time, companies need to process almost 75% of their data. They want to be able to use this data, and it's all the data that's coming in from off the edges of their systems. All the transactional data, anything coming in from IoTs, we've got to be able to use this data. It's not data that's already inside a warehouse. It's not data that's already been analyzed. It's real-time working on our data. And it's a real challenge for us. We're going to talk a little bit about why data lakes have such a big problem with this. By the time we get to 2025, we're going to have zettabytes, hundreds of zettabytes worth of data that we need to process, and this data is going to all be unstructured. We're getting more and more unstructured data coming towards us, and a lot more of it's going to be from devices that are out on the web. And so we need to start thinking about how to process this data. And before we, so I want to just have a bit of a disclaimer. I'm not a data scientist. I'm a solutions architect. I'm a software architect. I love technology. I love the idea of bringing cool tech together to be able to solve a client's problem. And the other thing that I do love is normal architecture. And anytime that I'm away, my family hates it. I'll see a cool building and I'm busy taking photographs of it. And this is a photograph of a building that I took while I was visiting Macau. This is the Robert Toe Hung Library. It was built in 1894. So it's very old, and this is going to be a bit of a theme in my talk today. We're going to take some very old data, we're going to get some very new data, and we're going to get it all working together. This was gifted to the city in 1955, became a library, and in 2005 they decided they wanted to build a really cool library, a more up-to-date and modern library, and so they built this library on the side with a beautiful garden, and you can go and have tea and all kinds of interesting things. And what really fascinated me was they took this concept and merged the two buildings together with this beautiful wooden staircase that kind of merges old and new together. And for me, this is what the data fabrics represent. There's this ability to reach across into our different data centers and data sources, be they old CSV files, be they database files, and merge this data together so we can all see it together presented. So what are these things called warehouses? So if you have a look at the color of my hair, you'll notice that I've been in the industry for a hell of a long time. I've actually grown up working with data in text files, then moving to ISAM databases, and then moving to relational databases. And relational databases were invented because we had so much data, and disks were super expensive, and we needed to get a better way to get the data onto disk. And then SQL came along and this is how we analyze the data. This is what we are pulling out. And after a while, we needed to start analyzing this data. SQL wasn't cutting it. These databases weren't working so nicely. So we moved into this concept of a data warehouse. Data warehouses are really focused on analytical data. And they generally run on our own tin, which is a slightly more expensive way of keeping things. And so we were constrained by the hardware that we had available to us. And that's not the only constraint on data lakes, data warehouses. We're going to have some structured data. Right? We can only use structured data. General users are our business users. The cool thing about data warehouses is that we can put some governance on them, so we can restrict who has access to the data and who doesn't have access to the data. And then, as I said before, these are generally used for business reports and metrics and being able to see some stuff about business. And the other interesting thing about warehouses is that schema is defined on write. So that's really, really constrained, because as you're working through your system, you go, hey, wouldn't it be cool if we could do that? And now we have to pull the data out, change the schema, put the data back in again, and sometimes we don't even have that data anymore, and so that is a really crappy constraint. Data warehouses still have their place, but their place has become limited in the world of having access to more data. So with wonderful people like Amazon and Microsoft and Google and all the other big players bringing easier to access disk space, we moved stuff into the cloud. And we created these concepts for data lakes. In data lakes, we brought all of our data, raw data, as much data as we could, and we started to throw it inside these lakes. All right, it's on less expensive storage, it's structured, and it's unstructured, so we could just start shoveling all of our data into these amazing cloud spaces, and it was there, and we could use it. And when we had to start inventing these new roles, data scientists need to arrive, and they now need to start analyzing this data and start working on the data. The downside of this is that we don't have any governance, or very little governance on, so we can't restrict who has access to it. You can't see this, you can see that. And in the likes of POPI compliance and HIPAA and GDPR and all of these rules that are starting to come in, that's not such a cool idea. Generally, we would have used AI or machine learning to start working on this data and starting to understand what we're going to get out of it. And the difference, one of the stark differences between lakes and warehouses is that we had a read schema. So we only defined the data when it was coming out, not when it was going in. So this gives us a huge amount of flexibility, but there's some trouble around trying to figure out what is our schema right, have we got the right thing? And so there are some restrictions around using data lakes. So one thing that was so cool about this data lakes is people had this dream that we would build this amazing space, and then we would provide these streams of data that would arrive in the cloud in these great lakes. Birds would chirp, and there would be water flowing down quite nicely, and we would just have all of our raw data. But it didn't work out so lucky, because we had no idea how much data was going to be pumping in. Often we had no idea what the structure of this data, how this data relates one item to the other. And so we had to get teams and teams and teams of data scientists, bearers of the data, walking under the load. And we created this new concept called a data mart. Think about it. It's this amazing market where you can get your sales figures and step right up, I've got your latest report. You know, that's the kind of idea. It kind of just conjures these ideas up. And so the answer to trying to move away from these data lakes where the data was smelly and you couldn't find your data and you didn't have any idea on your data because it was really difficult to work with, was to start out introducing this concept called a data mart and these ideas called these materialized views. So we'd have the data here, and then we would put it into this mart, and then we would have these materialized views which our business people could now analyze and work on this data. But the tricky part is we've got this middle piece here, which is just this big-ass ETL. We've got to extract the data. We've got to cleanse the data because it's all raw. We don't know. Like, some guys put some stuff in by hand. We don't know. Some of it is inconsistent. Maybe it's coming in from all kinds of structured, unstructured, social media, API endpoints. So we've got to cleanse it. We've got to extract it, we've got to enrich it, we've got to transform it, we've got to work it to the point of loading it, and now we're inside this concept of this materialized view. So that's cool, but it's a lot of work. It's a lot of processing, it's a lot of lifting things up and moving them forward, and lifting things up and moving things forward. And so the amazing people that we are, these ingenious comp-sci people, computer people, we've all got big brains. We decided, so far and so no further. Let's try and spin this thing around. And so it was born this idea of the data fabric. So what is a data fabric? Well, the first thing you'll notice from this slide is that it has far less moving parts. Well, you think so. As you get into the hood, it's got a fairly large number of moving parts. But a data fabric is essentially this. What we do is we go through this phase called discovery, where we understand our product that we're connecting to and our data structures, and we save a series of metadata about that data to a database, which defines a series of entities that we have inside our system. So these are metadata-defined entities, and the structures are now defined inside our application. On top of those entities, we can build other data objects, and so we're starting to compose objects with other objects, and we can start putting formulas and rules and all kinds of really fun technology inside these data objects so that we can now model our data and model the structure of what we're trying to actually work with. All right, so we haven't moved any data, we haven't pulled any data, we've just looked at the structure of what the data could look like and said, well, this is how we would like the data to look, and then modeled it in some modeling tools. And then when our business comes to us and says, oh, well, we've got this amazing data, we go to our business and say, we've got this amazing data, we start slapping on our tools like Tableau, Click, Power BI, those types of tools that all the business people would like to do. And they can look into the data fabric and say, give me my data. But there isn't any data. So the next part of a data fabric, after we've modeled it and configured it, is to actually compute it. And what happens is we come in, we ask to be pulled the data. The compute engine then goes and starts pulling all of the queries together, starts saying, okay, I'm going to get this data from here, here, and here, sends it down to a series of worker threads that are going to go off and collect all this data, merge it all together, and deliver it on a platter to our business users. Sounds awesome. All right. I'm going to pause there. I didn't tell you in the beginning, I'm happy for interactive questions. So if there's something that doesn't gel, or if there's something that's not making sense, put up your hand, and then and I'll answer that question as we go along. Do we have any questions? It's a good question. So the question is data fabric software or it's a concept? It's a bit of both. I'm setting up the concept for you guys now so that you can understand what the hell I'm going to show you next, because if I show you all of these moving parts, it doesn't really make a hell of a lot of sense. So it is software, and the point of me showing here is to get a concept going. Stefan.
Do you have examples of tools that fit the different?
Yes, I'm going to show you some of the working tools now inside the architecture of this, one of the products I've chosen. All right. So, did you have a question? Yeah.
In the previous slide, there was a section where there was transformation and enrichment transform. So, what replaces that in this one?
So what replaces, so the question is, in the previous slide, we had this very long ETL process. What replaces that ETL process? That's this model. That's where you're building the models, and you're putting your formulas inside here, and you can build models on top of models. So you can pull the data up, transform it in one model, pull it up to the next model, transform it in that model, and now you've got these layers of models that have moved data. So we're still going to do some transformation. We're just not going to necessarily do it and kind of leave this data lying all the time. All right, there's another question over there. There's a hand wavy at the right at the top. Oh, there's a beer. Sorry, I haven't. There was a question. Who answered the first question? Thank you for reminding me. I've only got 3 beers. You drink beer or chocolate? Chocolate. I've got 1 more beer. Lint, okay. All right, we're going to move on. So, I'm going to show you some technology. I'm quite excited about this technology. There's a number of different technologies that I could have chosen to show you today, but I'm going to show you this technology. The reason why I'm excited about this technology is because it is South African. So this is a young company in South Africa that has built a data fabric technology that Gartner has rated as one of the more innovative technologies, and is proudly South African. Love these guys. Really, really cool. Right. So the product is called Fraxis. It's by a company called Intenda out of Centurion. They also have offices in Europe. They also have offices in the UK and the US. And so they're expanding, and they're taking this technology out to the rest of the world. As I said, South African. So the technology that I'm going to show you today is Legos. That's the technology that builds and models this, the data that we're going to do. They have connectors to all kinds of different data technologies, and we're going to build some entities and some data objects and show you how it works. They've also got a product called Integrate. It's built on a really cool open source platform that allows us to do integrations and data flows. This is just in case we want to start manipulating some of our data outside of the technology, because we might need to do some additional data manipulations before we get our data into our own databases. They have a product called Insights, which allows us to build dashboards and graphing. I'm not going to show you Insights today, but a very cool product also built on open source technology. It's one other cool thing that we're going to talk about as we go through this. And then they've got a piece of technology called Opus, which is a low-code front-end development tool, which allows us to build front-end tools, web and mobile, onto Fraxis and integrate into Insights and integrate as well. So it's really cool. I'm quite excited about that. And the one interesting thing is just to talk about the genesis of Fraxis. Is the founder, or the guy who masterminded Fraxis, had a problem that he needed to deal with. He was dealing with FMCG, fast-moving consumer goods, and he needed to work out where products were going off the shelves faster than they were leaving shelves in other areas. And they needed to be able to move this product, like literally van A, we've got more product of product Z, get to position M, pull up the data, get it moving across. And they couldn't do this in real time. They couldn't use a data lake. They couldn't use the ETL tools because the products were moving so fast. By the time they got the product over there, the store on the other side now started to need it, and so they couldn't actually keep up with things. So this idea of this data fabric to be able to work with this data in real time is where it was born. So just to take a look at Fraxis, some really cool things that I like about it. First off, it's a microservice. It's microservice-based architecture, and that's cool for me for two things. If it's not doing what I want it to do, I can actually write my own services, plug them into the event bus, and actually allow me to enrich my own platform and really work on it. So it's got it's a very cool feature. The other cool thing about microservices is that if some part of the process is under a bit of strain, well, just spin up a couple more services. And so when I was working with on a project in the US and we needed to get some health data in, and there was one particular process that needed to write data faster than it needed to read, all we did was spin up more services in that part of the process. Microservices are very, very cool from that perspective. The other reason why I like it is it runs on Kubernetes. So it runs on all the cloud platforms, AWS, Azure, Google, and I can manage my processes as I need to. I can scale it down when I don't need to do lots of data processing, and I can scale it up when I need to do a huge ton of data processing. And the other very cool thing about this, and the thing as an architect that I love, is that this is built predominantly on open source technology. We've got Spark, Thrift, Kafka, Zookeeper, Elasticsearch, Kibana. Every single thing here is built on open source technology. And this is the one thing that I just wanted to raise with you guys, is that you can build world-beating products if you're going to get in and work on an open source technology. So something cool that I just wanted to share with you. Right, that's it. Move on. Let's go and take a look at Fraxis and what we're actually doing. So I've got some data. I've got some old Atari data and some new, that's a PS4, it's not that new, but I've got some data. We're going to bring some games data. The data is going to live in two databases. One is a SQL database, and it's an old SQL database. You will see it's old because the naming convention will give it away. There's a TBL naming convention, and there's an STR, DEC, INT. For the people that are laughing, they know they've inherited really bad databases where your predecessors always named their names TBL product, TBL something, because as if it wasn't a table. Views were named VW. I'm like, okay, cool. And every single column in the database was prefixed with the data type that it was. Heaven help you if you had to change the data type. Now you have to change the whole bloody column name. But anyway, you'll see it's an old database. We're going to bring some of the data. And then we're going to work on a new database, which is a Postgres database. But open source people, everything is lowercase with an underscore and a thing. And so it's a little bit more difficult, and we're going to need to manipulate the data to move it in and work a little bit better. So I've logged into Fraxis. First thing that you need to do when you're working with so the demo is running in the UK at the moment, so they might be a little bit slower. So here we go, games data underscore 1980 is my SQL database. Games underscore data PG SQL is for that particular reason. I put that like that because there's part of what we want to show in terms of merging data across two databases is important to know. All right. So the first thing that I would do is I would have discovered my database. So there's a little discover button there. First off, set up my parameters in Connect and run through discovery. I can set up who has access to this data source and how they have access to data and work on the governance rules right up front. But in the discovery process, it would have run through and found all the different databases and data sources and pulled out all the different schemas inside my data. All right, so I've now got this concept of entities. They're sitting in metadata. And if I head off to one of my entities, great. Somebody else has pulled some data in the meantime. Let me take a look here. Game sales. What's interesting, you can see I've pulled in some attributes. This is all just metadata. And what it's also gone and done is it's found the relationships between this table and all the other tables that it might be able to be linked to. So it's gone and discovered my data and told me a little bit about my data. So the next item, once we've got some data, is we're going to have to be able to build some data objects. And I built a few because I don't want to spend my whole demo showing you guys how to build a data object. I actually want to show you some of the concepts. But we have a data object here called Sales Post 1984. And we'll wait for that to load up. All right, so it's just a simple database connector. It's told me that I've got some tables that I can connect to. and I've gone in and joined those up, and I'm now going to flatten out some of this data to be able to show it inside a data object. I've got an opportunity to work with some of the data. One interesting thing about this technology is that it's got this item called push query. That allows the data fabric to work in a distributed mode. And what it does there is it actually pushes the query to your database technology, gets the data back again, and then merges it inside the Spark cluster when it actually goes. So now you're working in a bit more distributed. It's not only your cluster, it's your technology that's helping you, your database technology that's helping you pull that through. Another question. This source is from a relational database, but you can do it from non-relational. And I'll show you now, just when we get into the fabric thing, there's some other items. That's a good question. Do you want a beer or a chocolate? A beer. All right, we're out of beers, guys. Damn. All right. Okay. What I can also do, and I haven't gone into too many formulas because it just starts getting a little bit overkill, but what I've gone and done here is I've added a global sales item where you can see I've actually just gone and put a formula on here. So I can connect on this, go and edit my field, and I have a little calculation builder, and there's a whole series of different functions that I can have to start pulling my data out, manipulating my data, and working with that in some element of formula function. All right, so I now have a data object. I can run this data object and pull out some of the data, and I see that Wii Sports was probably one of the top games, and I can now clear that. A far more interesting, sorry, this is going to this. I just need to get my bearings again, sorry about this. A far more interesting data set is this 1980 to 84 data set. What's really interesting about this is I started to manipulate where I was getting my data from. So you'll see my database is called TBL_game sales. You'll see the nasty little column names in here that I can actually start pulling out and renaming the columns into something a little bit more interesting. And the data that I'm pulling out for the platforms is actually coming from the SQL database. But because I wanted to use a common set of publishers and a common set of genres, I'm actually going to pull the data from the other database. So that's the cool thing about the fabric. I mean, look up, so it's a stupid example, but I wanted to be able to show you guys how the concept of a data fabric. So I've got a table here. It's got some related fields to something in a completely separate data set. In this, I'm going to model them together, and when I run the query, it's going to pull all of that data together in the fabric and put that data through. So if I run this, you can see I've got the publisher name and the genre, which has now come from a completely different data set. And that's the power of the fabric, because that's what it's doing for me. All right. In order to complete this example, I want to quickly go in and show you that we've now got two data sets, and I'm able to now union those data sets, so I can union a series of different data sets. You can see here, we've got a little bit of a union, pulled the data sets across, renamed some of the columns, and pushed them into the system. And if I run that, I can now see the two sets of data merged. I mean, there's 16,000 odd rows of data in here, so I'm not going to pull all that data out. All right, so we cancel that. One of the interesting things about data fabrics is this feature called the data pedigree. And I'm going to quickly just show you what the pedigree actually looks like, because it's an interesting concept. So I showed you that total game sales. If I go and expect this, and it'll take a little bit of time to process, what it's going to go and do now is it's actually going to go and look at the data objects, get all the metadata together, and it's going to tell me how the data objects are all related to each other and where all the data is actually going to come in from. So you're going to see a data object at the top, the item in green. That's the union data object. That's going to tell me which data objects did I use underneath. So there's the post and the pre-1984, and there's the database tables that they'll come from. And you will notice that this post-1994 is using all the local databases, and this pre-1984 for 1994, so 1980 to 1994, is using the SQL databases plus some data across from the other database, and it's merged that all together and got that all sorted out. All right. So that's my demo on Data Fabric. Right, so that's cool, but you may want to go home and get started, and you can go and get started today. So I just want to quickly talk about this. I've got to make sure that I don't run over because I want to be able to give a few more questions. So inside Apache Spark, we have this, the core compute engine inside the technology you've had a look at is Apache Spark. Apache Spark is made up of Spark SQL, machine learning, Spark streaming, and GraphX, which is used for graph-type data sources. And it's going to basically runs workloads in parallel on a number of different worker nodes. The key concepts inside here is I'm going to show you is we're going to run a little jar application. Normally you write these things in Scala, but there's some Java here just to be able to get started. We start up an Apache session, goes off to a cluster manager. The cluster manager will break the tasks into a series of different parallel tasks, which will run onto a series of different worker nodes who have their own little memory cache. They'll then ingest the data that we need to. In this particular case, we're going to do a CSV file, so each one of these worker nodes is going to get a portion of that CSV file. It's going to work on a specific row record. It'll load the row into memory, do the transforms, and then in this particular case, we're not saving it. We're actually just going to show it to screen. But the idea here behind Apache Spark is that the data is immutable. So it starts off at a particular state. The internal engine will create a recipe for what needs to be done, and that recipe will just be applied as soon as we ask the application to run, and that's how we can run in this really powerful distributed mode and pull the data in through where we're going. Right, so let's build our own very, very quickly. I don't have a massive amount of time. I've got 2 more slides, but we've got a demo to get through. So this demo, as I said, is available on GitLab. What we're going to do is we start off by building our Spark session. We give it a particular name. We tell it we're working on our local database. That way it knows that it doesn't have to go off and find any of those sort of workers. We're going to create an instance. As soon as we create the instance, you'll see a series of different threads will start up. We will then build a CSV file, data file, and this is how simple it is to get a CSV file opening. So we're going to tell it that we want CSV. It's got a built-in reader. We tell it that we want the header records to be able to tell us what the data type, the data names are. We will infer the schema. We can give it a schema if we need to, but we're just going to infer it in this particular time. Tell it where to get the data. This is on my local machine. This data could be living anywhere. Be living on a site in an area that you wanted, or on a drive that you share inside your organization. Then we're going to do some transforms. We're going to rename some columns. We're going to drop a few columns, and I'll print out the schema and show you some of the records. And then we'll go and do the same thing by pulling the data from a database using a connection into Postgres. We're just running a Postgres in Docker on this machine. We're then pulling the data out. We can use normal SQL to be able to pull the data out, so that's really cool. And then we're going to do a lot of transforms to be able to get the 2 data sets together in preparation of merging. This particular data set doesn't have a global sales column on it, so I'm going to set it to 0, and we'll add that a little later. And then we'll move on to combine the data. So we're just going to union those 2 data sets. We're going to tell union by name, just merge all the data together. And then I'm going to create an expression on that data set to be able to add all the sales together, and then rename the columns, and then order by total sales, and we'll show off that data. All right, so let's just quickly run through debug mode and have a look to see what's actually happening here. All right, so we're about to get started, ready to run. I'm just going to run, let it set up. You'll notice on the left-hand side, you'll see a series of different threads all started up. It's ready to be running on my local machine, and the breakpoint is ready to move to the next line item. So it's going to run off, starting to load up that file on my machine. It's headed off and sent it to a series of different worker threads. So you'll see here, I've just shown you what the schema would look like. Using the print schema is very useful because you can actually then figure out what on earth your structures actually look like. So get into the habit of doing that. And I've pulled out all the data. Turns out that Asteroids is one of the top-selling games in this particular data set. All right, so we've now moved the data into a data frame and pushed it in, now got the CSV data ready to be moved into the next, we're going to then move on to read the database data. So in this particular case, let's just double check. There's the schema. We've now read the data from the database. That's our new schema. Remember, I told you we were going to add the global sales on. And now I've pulled the data out of my database. Just pulled out the top 5 rows of the data that I've got. And so I've got 2 data sets that we've got available for ourselves. Move on and do the union. And if we run through, we'll see the schema. And it's told me that in this particular data source, Wii Sports is the most popular game with probably 87 million total sales. And yeah, that's really, okay, really interesting. And it's one of the other interesting things. I think I've printed out the partitions. No, it'll do it when it runs. So let's just run this to the completion. So if we go down there, it said I've used 131 partitions. So it's taken all of that data, put it into 131 processes, and let them all run together, merge the data up together, and get going. I thought this was really cool. I mean, it's not as sexy as Fraxis. I mean, obviously, Fraxis guys have been working for many years, building out a very, very powerful technology. But being able to merge data from different data sets and get them all going together using a Spark engine, I think is pretty cool. Every time I see a young developer working with data sets where he's got to manipulate them and pull them in, I'm like, dude, come, let's talk a little bit about Spark and let's move forward. All right, so that's a little bit of a talk about building your own. I just wanted to talk about this really powerful pattern if you're going to be going into the data fabric space. I've been working with data fabrics for about a year and a bit now, about a year. And this is a particularly powerful pattern that I learned as I was working with more of the masters. It's called the common data model pattern. And the idea is to actually create a common data model that actually models your business as best as it could. And that model is what you make available to your business users so that they can understand it. And you model it in a language that's really useful for them. And then any of the other processes underneath, so you're getting data, in this particular case, this is an example, I'm working on a project now where we're pulling data from Salesforce Financial Services Cloud. They've got a particular naming convention where financial account and person account are these 2 separate concepts, and it doesn't really make sense for the particular business. So we pull them into this set of data objects, manipulate them into a structure that we need, which then ties back into our common data model. And on this side here, we've got a local database, which is more akin to our structure. We pull them into a common data model, and I pull them into data objects for processing and manipulation so that they get into the structures that we need, and then pull them up into the data objects. Another interesting pattern that I've seen at a few consultancies is to pull this in and work this as a common data model, and then have a series of these transforms at the top here. So if you've got another system that needs to speak in another language, pull it out that way and send the data out there, and another data output it out that way and send the data out there. But at all points, we've got a common data model of which we're working with. All right. And with that, the end of my talk, we'll open the floor to questions. I know we've had a ton of them, and I've really enjoyed this interaction. I am also going to look at the Slack channel, if I can find my glasses. And I will be with you in 2 seconds while I just unlock my phone. All right. I need to go back a bit here. All right. Question.
Where can you find a list of other products that you can connect to? So, for example,
Come and chat to me, and then we can actually see if I can find a URL for you and put that. So the question was, where could we find a list of all the connectors? Let's have a chat after this. There's another question there.
Hi. If you combine 2 different data sets, say one is a Couchbase and one is a SQL,
Yeah.
and union both data set,
Yeah.
what is the performance? Is there any performance improvement or any issues with the performance?
I'm trying to understand what angle you're coming at that. So the question was, if I had merged 2 different data sets together, one's a Couchbase, or like some sort of document database, and one's a relational database, what is the performance? Is that...
Can we get any performance issues? Or are we getting any performance issues? Then pulling this data straight out of the Couchbase and pulling data straight out of the SQL and work separately?
I guess the question is, what are you trying to achieve? The purpose of the data fabric is to be able to build a common model of how people can get access to their data and be able to go and fetch the data when they need to do it and get away from working with the heavy lifters, the data scientists that would need to do it. So there may be cases where it's not performant, and I haven't got to any of those cases where you may want to do that, and that might be a useful case to say, I'm going to pull the data out, put it into a slightly closer data store and move it into manipulation. That is a particular way, but I haven't been on the lookout for it. But I guess the question is, what business problem are we trying to solve? We're trying to solve a particular business problem in terms of making data available to people and letting them understand the data better, so it's not living in some sort of virtual data set. Okay. All right, let me see here. So I got a question here. Chetan, thank you very much for your question. Am I sending in virtual beers? No. Chetan was actually one of the junior programmers that worked with me when I first started working, so good to see you, mate. Okay, Stephen, thanks very much. One of my technical guys telling me that I've got a strange sticker. Oh, gosh. All right. Okay. I don't have too many questions, just many statements.
Hello?
Hi there.
Hi. Sorry, since I joined this the meeting, I'm new to like data engineering and stuff like that. So it's interesting the problem that the data factory solves, and you kind of already answered this question, but it was one slide, like disappointingly. So we're saying that we've got like businesses that have got all of these databases, like sales, for example, but they're all like living in different places. That last one, yes. Very last, second last, no, not. Our common data model.
Oh, okay.
Yes. Yes. So we've got like businesses that have got all of these data that they want to do, like sales for games, and they've done them with like different technologies and all of that. So I was just curious, with like something that is like common data model, isn't this something that is a solution to data fabric, so that if I'd started with something like this, and then never mind what technology I'm using, I'd never be in a point where I need to be using something like data fabric?
The point of the data fabric is to do this, is to be able to get the data in real time as we're getting it across and not have to do the manipulation through many different ETL processes to get it into the space that we want to do it. And that's the idea behind the fabric. And the other idea is to be able to reach to these different data sets, these disparate data sets, merge the data together and move it across when we actually need it. So you could do it like that. There's no reason for not doing it like that. And in certain very complex data structures, you would have heard this term called data mesh. The data mesh idea is where people actually start owning their data as a product and then working on their data and then use a fabric to pull all the data together and then serve it up together. So preparing some of that data in the mesh could actually have been some sort of ETL process, like you said, to be able to get it into some common form and data model.
Sorry. Are there companies out there that have got like a data-first approach, like data is like first-class citizen in their company, where everything you build, you're building around that, and everybody's got this like common knowledge? And like, how does it work in your experience? Is it good, or does it not work out?
I think everybody is moving towards data first. To me, it feels like that's the most important aspect: understanding your client, understanding your product, understanding whatever is in there. So moving to data first is naturally going to be a far better process. I still think we've got people that need to understand that better. I don't think that it's necessarily data scientists. I don't necessarily think it's developers that understand how to put that together. And I think there's an exciting space available for business people to start educating us a little bit better on how to work on that. Guys, I am over time. I'm happy to answer as many questions as you want. I'm eating into your lunchtime at the moment, excuse the pun. But I just wanted to say thank you very much for spending time with me. That was great. Thank you.